My name is Steve Mykytyn. I'm the technical trainer here at AprilAire, and thank you very much for taking time out of your morning to attend our NATE ventilation class. We've got a lot to cover. I want to make sure that I get everything covered that I think is important. We've got a lot of people signed in for this morning's webinar, which is great, but it means that I'm not going to be able to get to hardly anybody's questions, of course. So please use the GoToWebinar tool to submit your questions. And like always, I'll do my best to answer them as quickly as I can. Usually takes me a couple days just because of the volume of questions. It is a NATE class. So when you registered, you probably submitted your NATE number, so you're all set. If you're not sure, you can certainly, again, just submit your NATE number using the GoToWebinar tool like you were asking a question, and we'll take care of it that way as well. Just a shout out, in addition to just the general group of people listening in. If you're listening in because you're involved in new construction, either as a HVAC contractor or a builder, a rater, an engineer, etc., I would like to just make you aware. We have a residential new construction, an RNC channel marketing manager, Joseph Hillenmeyer. You're more than welcome to contact him. You can see his email there, or again, just submit your information to using the GoToWebinar tool, and I'll make sure that it gets to him as well. So let's get started. So we're going to be talking about ventilation today. I want to make sure that we kind of build the case for ventilation. We'll talk a little bit about codes to help frame up the fact that we don't need or even want to become experts in codes. Building codes are something that, it's a rabbit hole. So I'm going to just assure you that that we've got the building codes covered, and then we'll talk about different types of fresh air ventilation, and then we'll wrap up with our products. So, fresh air ventilation, why do we need it? Well, new construction materials used in homes contain VOCs, volatile organic compounds. For example, formaldehyde. These are going to outgas over the lifetime of the product. Most of the outgassing occurs towards the first year or so of the product, but it typically continues for a very long period of time. Also, adhesives and plasticizers and all those kinds of things. Think about the new car smell, right? When you buy a brand new car, that smell is all the VOCs leaching out of all the plastics. Also, homes that are built on site, they're going to be exposed to the elements, so they're going to absorb and release moisture. For example, have you ever seen it rain at a construction site? Of course, always rains at a construction site. That means when the home is built, those materials have more moisture than they will once they reach equilibrium. So that moisture is going to come out. I want to make sure we can address that. Because everyone knows, or certainly the knowledge is increasing, that VOCs are present and bad for you, you'll see a lot of builders that are advertising that they use low VOC paints, low VOC flooring, etc. Once the home is occupied, the furnishings themselves, all the finishes you apply, the stains and the paint and everything else, household cleaners, the simple act of cooking releases humidity and oils into the air. All of the air fresheners that we use, all those things add to the VOCs in the air, as well as small particulate. If you walk into a house and you can smell last night's dinner, that means it's a very tight house, but it also means that if those smells aren't leaving, it's unlikely that the VOCs are also escaping from the home as quickly as we would like. And then how long can you smell that paint in the house? That gives you a sense for how quickly those VOCs are escaping from the home, or how slowly. You combine that fact with the reality that people spend pretty much all their time indoors. The EPA says about 90% of our time we spend indoors. And then lastly, homes are being built tighter. So there's more chemicals in the home. We're spending all of our time indoors, and the homes are tighter. So that's why we need ventilation. Ventilation solves the problem because the solution to pollution is dilution. Why do we install ventilation? So that was why we need. Now this is why we install ventilation. Well, now we're starting to just touch on the codes. And I want to make sure that I help you understand the alphabet soup of abbreviations out there, but I also want to make sure that you're comfortable with the fact that even though the building codes seem complicated, the fresh air ventilation really is very, very straightforward. There's two guidelines on fresh air ventilation. The IRC, which is the International Residential Code, and we're using the 2015 version. That's still the one that's applicable. And you can read there, that covers pretty much most of new construction, residential new construction, detached 1- and 2-family dwellings, multiple single-family dwellings, often known as townhouses, 3 stories and less. That's the bulk of it. There's a different code, the 2015 IMC, International Mechanical Code, that covers everything else. So you'll hear IRC and IMC. Besides just meeting building code requirements, there's other reasons why people install ventilation. Builders use it as a way to differentiate themselves in marketing. For example, they can say, we offer Energy Star homes. We offer green built homes. LEED is a very popular thing that you advertise. I have a LEED gold home or what have you, LEED certified home. The EPA has an Indoor Air Plus certification. There are ways for a builder to differentiate themselves, a way possibly for a builder to charge more money for the home. Here's the key to all this. That one little bullet point there. Hopefully this gets rid of a lot of confusion. The mechanical ventilation system shall be installed to meet the requirements of ASHRAE 62.2/2010. So that's what we're looking at. The IRC that we talked about last page, the IMC, those are based on that ASHRAE guideline. And that is a very simple guideline. It's how many square feet is the home, how many bedrooms is the home. It's as simple as that. So hopefully that helps you understand that there's a lot of building codes, municipal, state, city, all kinds of things like that, but they're all based on that code. So if you have a product that meets ASHRAE 62.2/2010, that means it's going to meet IRC, that means it's going to meet IMC, and that means that whatever they've adopted for a building code, full or part, we know that we're going to meet whatever building code they have because we meet that most strict guideline, that most basic universal guideline. So not so bad, not so complicated anymore, hopefully. A little bit more about codes. And if this goes in one ear and out the other, that's fine. I just want to, again, help you understand some of this, all this, the parts and pieces, the moving pieces here. The International Code Council updates the model codes every 3 years, but these are just guidelines. They're just words on paper. Each state can choose to adopt the latest version of the model code, and they can determine if the local municipalities can make changes. So that's why you can have a state, a county, a city codes for new construction that are slightly different. But again, no matter what that building code is, it's going to be based on whole or in part IRC, IMC, which again is based on the ASHRAE code. So as long as we meet that ASHRAE code, we're good to go. Once those codes get adopted, then they're enforceable. To fine-tune that message a little bit, the IRC and the IMC use that ASHRAE guideline to figure out how many CFM of fresh air ventilation. You know, you've got a house of a certain square footage. It's got a certain number of bedrooms. Oh, I need 75 CFM of fresh air. That's what those guidelines dictate at their core. You may also be in a part of the country where the local building codes want you to meet IECC, the International Energy Conservation Code. And all this is they're still requiring that you meet that IRC, IMC thing. So, you know, the ASHRAE guidelines. But this also adds in how much electricity you can use to bring that fresh air in. So, in my example, you know, I need some amount of fresh air, 75 CFM. IECC says you need to be able to bring that fresh air in by using not a lot of electricity. We'll get into the particulars in a couple slides. So again, don't overthink it. Don't get into a debate or a conversation about building codes. Don't feel that you have to read the building codes and understand the building codes. Find a product like AprilAire products that meet those IRC and IMC guidelines, and you know you'll be fine. No matter how loose or strict the building codes are, you know you'll be fine. You'll hear a lot of dates thrown out, so that's why I put that at the bottom there. With regard to ventilation, the 2015 version is the same as the 2012 version of the IRC and the IECC. So don't overthink it. ASHRAE writes the guidelines, specifically ASHRAE 62.2. That's what everybody's going to follow. So both the 2012 and the 2015 versions of IECC and IRC, they still use that same 2010 ASHRAE 62.2. So no changes there. All right. Let's stop talking about codes. Hopefully that made it clear that you don't need to become an expert on building codes. There's no sense in getting into a conversation about it. There's so many moving parts and pieces. And quite honestly, there's so much misinformation out there. I want to take a second here and kind of shift gears a little bit. You're going to hear a lot of conversations about air changes per hour when you're talking about fresh air ventilation. When we're talking about indoor air quality, we're usually talking about estimating how many air changes per hour. You know, half an air change per hour, 1 air change per hour. That helps us do things like size a humidifier or size a dehumidifier. That's the real world air changes that home would experience. 1 air change per hour means that every hour, essentially all the air in the house gets exchanged with outside air. Half an air change per hour means every 2 hours or 12 times a day, all the air gets exchanged. So that's the actual house as built sitting in the location. That's the real world. That's what you would get if you did like a blower door test, as a way to calculate how loose or how tight that home is. They do some extrapolating. That's different than all those building code guidelines that you see that talk about CFM 50 or ACH 50. That's using a blower door to specifically pressurize the house to a specific pressure. 50 pascals, that's where the 50 comes from. What are 50 pascals? 2/10 of an inch water column. We all know that, what that is. 2/10 of an inch, we can picture that. 2/10 of an inch water column. So it's not a real world test. They pressurize the house to that pressure, and they see how leaky and how tight it is. So think of it like the miles per gallon rating on your car. It's a way to compare 2 cars or 2 homes. It's not a guarantee that that's the real world performance. No one assumes that. Everybody drives differently. Uphill, downhill, too fast, headwind, whatever, right? Towing a bunch of stuff. That's going to change your miles per gallon. It's a way to compare two cars, just like CFM 50 or ACH 50. There's a way to compare two houses. So don't confuse it. If someone says they have 3 ACH 50, that is not 3 air changes per hour in the real world. 3 air changes per hour is crazy loose. That's like a treehouse. So hope that helps. Again, trying to make it less confusing. And I'm just going to click through this quickly. I don't want to spend a lot of time on it. This is the nuts and bolts of how you calculate how much fresh air you need. It's CFM of the house times the area times number of bedrooms plus 1. And it can be run intermittently for no less than 1 hour every 4, and the average ventilation rate is that 4 hours must equal to the continuous ventilation rate. I'm going to skip over that. Just understand that's the formula. We'll come back to that in a little bit more detail. Let's talk about some different kinds of fresh air ventilation. We've got exhaust fresh air ventilation. This is like a bathroom fan. We've got supply fresh air ventilation. This would be a fresh air ventilation product that's bringing fresh air into the home. So a bathroom fan obviously exhausts air from the home. Supply air fresh air ventilation would be pulling air into the home. And we'll talk about the pros and cons. And then finally, balanced fresh air ventilation. This is like an ERV or an HRV, where we're bringing in an amount of fresh air and we're exhausting the same amount of stale air. We balance the system, so the CFM is the same. In exhaust fresh air ventilation, we're depressurizing the home, so fresh air leaks in around windows and doors and stuff like that. Supply fresh air ventilation, we're pressurizing the home with fresh air, and so the stale air leaks out. In balanced, you're neither pressurizing nor depressurizing, you're balanced. Let's talk about a balanced system briefly. So ERV, HRV, you've got 2 penetrations to the outside house, one bringing fresh air in, one exhausting stale air. The stale air and fresh air is going to pass through a core. If it's an HRV, you're transferring just the heat energy. If it's an ERV, you're transferring heat and moisture to sort of precondition that fresh air coming in. So you're not going to have to heat it and cool it as much, and perhaps you won't have to dehumidify and humidify it as much. These are expensive to install because of all the ducting, and you have to balance them. So you have to take the time and have the skill set and the tools to balance the 2 airflows. But they're inexpensive to run. And so what we're doing is we're pulling fresh air in from a selected location, and we're pushing stale air out from a selected location, 2 penetrations to the outside. You accomplish fresh air ventilation while recovering quite a bit of your energy, so that lowers the overall operating costs. It gives you a theoretical payback. The HVAC contractor is the one to put it in. Obviously, new construction is the easiest time to put something like this in. And you see these as being encouraged, or in some cases mandated, in Canada and in some northern states. Certainly encouraged. And I talked about the cons. Expensive in parts, expensive in labor. Does take up a fair amount of room because you do have 4 ducts coming off it, plus the physical size of the unit, and you've got 2 penetrations. Let's talk about the supply system. So, passive supply system. We're going to cut a 6-inch round hole in the side of the house, put a vent hood and a burst screen on it, run 6-inch round insulated duct to a motorized damper. That damper then is going to have a duct running from it onto the return side of the HVAC system. You have some kind of a control, hopefully, to open that damper and turn on the HVAC blower to provide the calculated amount of fresh air ventilation that you need. The key here, of course, is we're using the HVAC blower to bring the air in. And we're selecting a place to pull that fresh air in. By pulling that fresh air in, we're pressurizing the house, and that pushes the stale air out of the house. We'll get more into the AprilAire products later on in the presentation, but it's a normally closed motorized damper with a control, or of course you can use any number of ours or other companies' IAQ thermostats to control that. This is inexpensive to install. The challenge is that you are using the HVAC blower to bring in the fresh air, so it will meet IRC and IMC, but it may not meet the IECC energy requirement, simply because it's using the HVAC blower to bring that fresh air in. If you have a variable speed blower that uses such a small amount of electricity, it's possible that this solution would also meet IECC. So what's a step up from that? Well, instead of using just a damper in the HVAC blower, we can use an actual power ventilator. So it's got a high efficiency fan or blower installed in it, so we know we're going to meet IECC. It's going to move a lot of air, so we're not going to have to run it very much to meet the fresh air ventilation requirement. That's nice. That means that we can usually piggyback the fresh air with existing heating and cooling calls or fan calls. And the control, of course, would need the ability to make the HVAC, to make the power ventilator run, and if desired, make the HVAC blower run to help mix that air. Again, still ducted into the return, so you can temper that air and you can filter that air with a high efficiency whole home air cleaner. The nice thing here is we don't need to run the HVAC blower to bring the fresh air in. And so that doesn't count as part of the power requirements of the fresh air system. All right, so let's get into a little bit more detail. So we talked about balance. Now let's get into this in more detail. Supply side fresh air ventilation, we're bringing fresh air into the home. So we're selecting a location to pull that fresh air in. So we pick a place that's not near, a dryer vent or a bathroom vent or a furnace flue, you can imagine, right? So we know we're getting good fresh air. That fresh air is pulled into the home, we pressurize the home, and then the stale air is pushed out through cracks around windows and doors and wherever else it can leak out. So we are truly getting fresh air coming in, and then that stale air simply pushes out. So we can select a good location for that fresh air. By ducting it into the HVAC system, we're going to distribute that fresh air very effectively using the ducts. I've put in several of these as retrofits. It's not that difficult. It's minimally invasive. You cut a hole in the side of the house. Then you've got some insulated duct. You mount that cabinet and duct it into the HVAC system. And then typically you're going to wire it into the HVAC system as well. And like I said, because we're running it into the return, we can both temper that air, mix it, and then filter it. Does cost a little bit more than, say, a bathroom fan, and change can be scary. Change is always difficult. How much time is this going to take? All those kinds of things. But let's compare it to what we see now. What do we see now? We see bathroom fans now. Use a bathroom fan. So what does that do? Well, it moves the amount of fresh air that ventilation requires. So you meet that requirement. But let's think about its operation for a second. What's it doing? It's pulling the stale air out of the house. So we're picking where the stale air exits the house, which depressurizes the house. That means we don't get to pick where the fresh air comes from. It leaks in from wherever it can, around windows, around doors, what have you. So that air may not be all that fresh. It may be leaking in around a window that is close to a dryer vent. close to furnace flue, close to bathroom vent, kitchen vent. You get the idea. Also, who installs a bathroom fan? Not the HVAC system, not the HV contractor, I mean, electrician. But who's going to get the call when there's a problem with, let's say, humidity? Well, it's going to be the HVAC contractor, not the electrician. So the key here is we're negatively pressurizing the house by pushing the stale air out. And that then gets equalized by fresh air being sucked in, but we don't get to pick where that fresh air comes from. So it's not as fresh as we'd like, and we don't get to filter it, we don't get to temper it, and it certainly isn't being dispersed throughout the house effectively. Think about an attached garage, for example, and I'll go through some more bullet points here. So just to hammer it home, we don't know where that fresh air is being pulled in at when you use a bathroom fan or exhaust ventilation in general. That means that it's going to be passing through those exterior walls. So anything that's in the path of that air being drawn in is going to become contaminants that are pulled inside the home. Think about an attached garage, all the things you store in an attached garage. Do you let your car idle in that garage? That could be your quote-unquote fresh air being pulled in under that attached garage door. If you depressurize the house enough, you could imagine, depending on if your hot water heater is a power vent or not, you might have problems exhausting the combustion gases from that water heater, just as an example. Another thing to think about is the way a house is designed. It's not designed to inhale, but it is designed to exhale. You've got flop dampers on your kitchen vent, on your bathroom vents, on your dryer vent. When those things are running, they're pushing air out, and so they're popping those flop dampers open. When you pressurize a house, that also pops those backflow dampers open. So it's very easy to bring fresh air in, pressurizing the house, and then the stale air has lots of places to leave. If you're running a bathroom fan, pushing stale air out, that's depressurizing the house. That's going to just pull those flop dampers closed tighter, forcing that quote-unquote fresh air to be pulled in through those leaks around doors and windows. I mentioned this before about the electrician being the one to typically install it. Because of all these reasons, it's not as effective in terms of delivering fresh air. I want to point out a couple things. When you negatively pressurize a house, if you do have a radon mitigation system, that can make that radon mitigation system less able to exhaust the amount of air it's supposed to. And then also think about what can happen if I'm exhausting stale air out, pulling fresh air in. If I'm in a hot and muggy climate and I'm keeping my house nice and cold, it's quite possible, because I'm pulling that outside air in through the exterior wall, not in places I pick, just wherever it can get in, it's quite possible that I can get condensation occurring inside of that wall. I've done this presentation to some HERS raters, and they have commented on that, that is something that they've seen. So let's talk about that a little bit. We've got a variety, like we talked about before, a variety of different reasons that you might want to do fresh air ventilation. For example, one of those would be thinking about it in terms of a home builder doing some positioning as a way to differentiate themselves. So not just building codes, but ways to differentiate themselves from other builders. One of those is a HERS rater. HERS is an acronym. It stands for Home Energy Rating System Index, and it assigns a number. You can see there the least energy efficient home has a larger number than most energy efficient home. I'm just using Beazer as an example. They gave us some good data, so I want to share it with you. Here's how they position themselves. By making themselves an Energy Star home, they're able to make some claims, and because Energy Star has some requirements that you prove it, they can document it. So look at this. A resale home, 2 stories, almost 3,000 square feet. Their electric bill, a little over $300. Beazer, new home, 2 stories, almost 4,000 square feet. Electric bill, about 56 bucks. That's a huge difference. That's something that someone can appreciate, whether they really understand Energy Star, fresh air ventilation, building codes, what have you. But picking products that are Energy Star certified, becoming an Energy Star certified home is a great way for Beazer to position themselves differently from the competition. All right. Let's talk about this in a little bit more detail. I've alluded to this a couple times, but I want to make it simple. IECC, that's an energy requirement. All we're saying is 2.8 CFM per watt for the fresh air ventilation. What does that mean? For every 2.8 cubic feet per minute of fresh air I bring in, I need to consume no more than 1 watt. That's all it's saying. So that's energy efficient. So 3 CFM per watt would be even more energy efficient. That's going to require the selection of an efficient fan to deliver that fresh air into the home. And I'm just going to show you this table. You guys have seen this table before. If not, it's very simple, very easy. This is the guideline for how much fresh air ventilation. So IRC, IMC, based on this. How big is your house? How many square feet? 3,000 square feet. Okay. How many bedrooms? 3 bedrooms. Okay. You need 75 CFM of fresh air. It's as simple as that. If I can deliver 75 CFM continuously, I meet ASHRAE 62.2/2010, which means I meet the current IRC, IMC, which means I'm going to meet any building code in the United States. If I can deliver that at 2.8 CFM per watt or better, I'll also meet IECC if that's something that your local building codes require, or if that's something you want to do to differentiate yourself. As simple as that. Boil it down to that. You get that. Look for products that meet those things. You don't have to worry about the rest of it. And then that's the formula, but that formula is simply how you get to that table. So use the table. All right. So AprilAire has done all the work for you. Our engineer, Scott Gresheim, has done the work. What we've done is we've designed products that meet IRC, IMC, and also will delineate which ones meet IECC as well. We've got several products because we know that when we're bringing fresh air in, that fresh air, depending on where you are in the country, is going to be cold or hot or humid or whatever, right? So that's going to present unique challenges depending on where you are in the country. So you take the continental United States, you divide them up based on the outdoor air conditions, and if it's marine or dry or moist. And so you can see you've got color bands with numbers, and then you divide it up into 3 regions horizontally. So Madison, Wisconsin, we're in region 6, and we're moist. So what does that mean? Well, we've done all the hard work for you. This is right out of our brochure. So we said region 6, moist. That's 3rd from the bottom, cold and moist. Toronto, Vancouver, Milwaukee, Madison, Minneapolis, St. Paul, Sioux Falls. There's some examples of major cities. What do we recommend you put in? The model 8140. Okay, how do I install that? Duct it to the HVAC return. That makes sense. Why do I do it that way? Well, you install the fresh air ventilator to the return side of the HVAC system and wire the control to turn on the HVAC system's fan with fresh air ventilation to ensure good air mixing in the winter. Dehumidification is also a benefit from return side installation. The air conditioner is running, you can dehumidify that air. It's as simple as that. Now you're the expert. So you don't have to understand, I'm going to go back to that map of the United States briefly. You don't have to understand the details of a given state or city or municipality. We know that we're going to meet the most strict guidelines, the letter of the law of the IRC, IMC. So it doesn't matter what the building codes say, they're going to be either as strict or less strict than that. Again, make your life simple. Don't overcomplicate it. Find the region you're in. If you're in Miami, you're 1, way at the bottom there, moist. Look at the table, 1 moist. We're going to put in a product called an 8191 or an 8192, and we're going to duct it to the return. We don't even know what those products are. You've already got your equipment selection made, and you've got a reasonable explanation for why we think you should put in that product. I don't want to go through all the regions, but let's look through a couple. So you can see it's based on things like proximity to the coast, how hot your climate is, how humid your climate is. You can see it's just a very simple matter. Most people are only going to have one number in one area. You might have a region that spans a couple. The little squares are counties, so it gets pretty granular. So at most, you might have a couple different, maybe you're 4 and 5. But again, not a lot to worry about. Very simple, very straightforward. And this is a brochure. It's available on our website, AprilAirePartners.com. You can reach out to your district sales manager, AprilAire district sales manager. They can come out and do a training class for you, what have you. Very simple, very straightforward. All right, let's talk about our products in more detail. So again, this is out of that brochure. You can see the full family there. We're just going to go into each one and cover them in a little bit of detail. So again, going back to the map of the United States, as we're going through this, you're going to see that each product is going to reference which regions it would be applicable for. So you get the numbers that we're talking about. And then marine, dry, and moist. All right, let's jump in. Model 8140. It's a complete unit, so it's a cabinet, insulated, with a high efficiency blower and a control and a 3-prong grounded plug. It's got a motorized backflow damper built into it, and it's got an inlet and outlet collar. So the inlet collar, the duct that would be running to the outside, 6-inch round. The collar on the outlet side, so what would be delivering the fresh air to the HVAC return, is an oval collar. Contractors asked us for that. They said that oval shape is going to be easier if they have to wind that through the basement or wherever. Maybe they have to fish that briefly through an interior wall. Who knows? They said that oval shape works better for that application. You just use regular 6-inch round duct and you ovalize it. So 6-inch round, typically insulated, ovalize that, and it makes your life easier. We've picked a blower that's very energy efficient, and so you can see it meets all those requirements there. You've got your ASHRAE 62210, IRC, IECC, Title 24, et cetera, et cetera, et cetera. And this would be used in regions 3, 5, and 6. We also offer this same exact model without the control. If you wanted to control the product with an IAQ thermostat, either AprilAire's or someone else's, you could just order this unit without the control and then control it with that external device. 8141, same basic design, but instead of a motorized damper, it has a flop damper, a backflow damper. Same blower, so therefore meets the same requirements. If you just need to meet the fresh air CFM requirement, but you don't need to meet the energy requirement, the IECC, that 2.8 CFM per watt that I've mentioned a couple times, there's a very inexpensive product, that model 8126X. Comes with the same control, comes with a 6-inch round, normally closed motorized damper. So you're still going to be able to open and close the fresh air so you don't get too much, you don't get too little. And it comes with a transformer, comes with an outside temperature sensor. So that gives us the ability to do some lockouts based on temperature. One of the neatest features of our control, one of the groundbreaking features of our control, is that historically you've had to choose between meeting ASHRAE guidelines, so bringing in the amount of fresh air you need, or having lockouts, so you don't bring fresh air in when it's too hot outside or too cold outside. Our control lets you do both. What it does is, You're going to program it for how much fresh air you need, obviously. But it's going to sample the air temperature outside to see if that air is too hot or too cold based on guidelines that you set. If it is too hot or too cold, it will defer those fresh air ventilation minutes until later on. It doesn't skip them, it banks them, it keeps track of them. So let's say you needed, I don't know, 20 minutes of fresh air ventilation an hour. And let's say right now, excuse me, right now, fresh air ventilation, we want to run it, but it's too hot outside. So that control would say, okay, I'm not going to ventilate this hour. I'm going to bank those 20 minutes and add them to the next hour. The idea is that over the course of a year, we're going to be bringing the fresh air in when it's more mild outside. So we miss the hottest times of the day and the coldest times at night. That's the idea. And that adds up over time to a significant energy savings while still meeting the new building code pressure ventilation requirements. If you're doing multifamily applications, we have a specific product for that, the 8144NC. This is similar to the other products, except for two main differences. One, the multifamily requirement is that we bring in the fresh air continuously. So we can't just bring it in periodically to give us the total amount of fresh air ventilation we need over the course of a 24-hour period. That multifamily, that IMC requirement is that we bring in the fresh air continuously. So this is a variable speed blower. And so there's a video that you can watch at AprilAirePartners.com that goes through how to set this up. It's very simple, it's very straightforward, and it allows you to slow down the blower so that you're providing just the CFM of fresh air ventilation that you need for that application on a continuous basis. It's a very compact design because it's going to be used in a lot of, apartment equipment closets. Don't really have time to go into it in a whole lot of detail, but I just want to show you this is the spec sheet that either your AprilAire district manager can get, you can call our tech support group, they'd be happy to discuss it with you or email it to you, or you could download it yourself off of our website, AprilAirePartners.com. There's a picture of it. You can see you've got a variable speed fan control, so you can slow it down. You've got some airflow versus back pressure curves there, some fan curves. That's what I was looking for, some fan curves. And you can see you've got the oval collar and the round collar. There's also pressure ports built into it, make it very, very easy for you to check your static pressure so you know exactly how much fresh air you're bringing in. Rounding out the whole concept of a fresh air ventilation product line, we get a lot of requests for makeup air. Someone has in their kitchen, either new construction or they've got their kitchen remodeled and they put in a large, multi, 8-burner stove, and they put in that really nice stainless steel commercial vent hood, and that commercial vent hood's going to pull out 1200 CFM out of the house. Well, you can't pull 1200 CFM out of a house without, really depressurizing that house. That's a lot of air to pull out of a house. And so that causes problems. Obviously, you can start to drag in, fresh air from the outside that can create problems with humidity, all the things we talked about with using a bathroom fan. It can cause problems with, if you have a non-power vented water heater, for example, just a variety of issues associated with that. If it's running a lot, then it becomes difficult for other fans in your house to exhaust because it's depressurizing the house. So all this is a larger normally closed damper, 8-inch or 10-inch, because we want to make up, a good chunk of air. Certainly not all the 1200 CFM. No one would want that. This is just making up enough air so that that's not an issue. A transformer to run the normally closed damper, and then a current sensing relay to make it very simple, very easy, so that whenever you're running that vent hood, we simply power that normally closed damper open. And then we're depressurizing the house, so we draw air in through that damper. Simple as that. So cut a hole in the side of the house, that 8-inch or 10-inch round penetration, vent cap, bird screen. You can duct it or not. You can locate it wherever makes sense. Again, all we're doing is making up for the fact that we're depressurizing the house with this grossly oversized kitchen exhaust hood fan. Rounding out the line, this is used in just a very small part of the country, the 8142 NC. This is used in parts of the country where the attic is not considered a space that the consumer can get to. And since the attic isn't considered a space the consumer can get to, like for example, Arizona, that means that you can't put a filter in that space. If you have a filter, the consumer has to be able to get to it. So this is a model that doesn't come with a filter. You can have it with the control or without the control. The 8142 has the control, 8142 NC does not. Other than that, same high efficiency blower. It has a flop damper, backflow damper, and because it has that high efficiency fan inside of it, it's going to meet both IRC and IECC if that's something that you need to do. But again, very specialized location, parts of the country, but we have a product for those applications. We also have an ERV. We talked on ERVs briefly. Our ERV is the model 8100. And then if you're in parts of the country like, say, Florida, the Gulf Coast, the Atlantic Seaboard, we also offer a ventilator that dehumidifies. That's the 8191, 8192. Same basic control. Gives you the ability to bank your ventilation minutes if it's too hot or too cold outside. But we are using these in parts of the country where it's a new construction home, well-built, tight home. Air conditioner is doing a perfectly good job cooling and dehumidifying the home. But we know when we bring fresh air in to meet the new construction building code, we're going to be bringing in fresh air that is so humid, we're going to create a humidity problem. So by using the 8191 or the 8192 in those parts of the country, we're going to be able to dehumidify that fresh air as it's being pulled in, so we don't add a huge moisture load to the house and then try and dehumidify it. Once we've added a huge moisture load to the house, we can knock it out at its source as we're pulling the fresh air in. Very popular in Florida, very popular Gulf Coast states, and then even up in the Atlantic Seaboard. And then final shout out to our tech support group. If you're not familiar with our tech support group, they've all installed our products. They're all very familiar with our products. In fact, we just did a demo installation in a person's home last night, installed some IAQ products. So everybody in our tech support group has literally installed our products. Besides being trained, being familiar with the industry, being able to do product selection and application guidance, and of course troubleshooting, they actually have hands-on experience. So if you're having a problem, call them up. They're not going to push you through a flow chart of pointless questions. They're going to have a conversation with you. They're going to be able to help you figure out what's going on. Our goal is, can't always do it, but our goal is one call resolution. So in one call, either we get the product working or we figure out what what component is causing the problem. You can go back to your distributor and get that part and get the product working. Managed to cover everything I wanted to in the time we were given. I try and keep these under an hour. We're just bumping up against that now. I'm going to leave the GoToWebinar tool open just for a couple more minutes to give you a chance to submit any questions you might have. I'm going to leave it on this screen. The two things to see on this screen are our contractor-only website, AprilAirePartners.com. That's AprilAirePartners with a S on the end.com. That's going to be contractor-focused stuff. So installation manuals, spec sheets. It's where we have a lot of training videos. It's also where we have marketing materials. If you're not familiar with our co-op program, this is a great opportunity to reach out to your AprilAire district sales manager, and they can talk to you about that. Or of course, At the bottom there, our 800 number, you call into our customer service and tech support group, and they'll be happy to explain all of those features and benefits to you. This is also where we save all of the recorded webinars, like this one. In a day or two, you'll get a follow-up email with a link to this recorded webinar. If you go to AprilAirePartners.com, you'll see additional upcoming webinars as well as a list of recorded webinars that you can listen to. Just want to point out, because there's always a few questions about this, NATE credit is only available for listening to a webinar live, or of course having an AprilAire District Sales Manager do the training live to your group. You do not get NATE credit. This is a NATE decision, not us, it's a NATE decision. You don't earn NATE credit by listening to a pre-recorded webinar. So 800 number there, 334-6011, an excellent resource, as well as AprilAirePartners.com. Thank you very, very much for your time. I really appreciate it, and enjoy the rest of your day.